So when you look at the assignment in your book, there's going to be two types of questions, either vertical angle equation or complementary. So it's kind of similar steps, but different problems. So we're going to do two separate lessons. Today we're going to focus on vertical angle equations. Do it one thing at a time. And what did we kind of allude to about vertical angles? As far as if one vertical angle is 30, what's the other vertical angle? Yeah. So we're about to go ahead and look at why that's true. Remember, two angles, just like he just said, vertical angles are two angles that are on opposite sides of an x. So for example, these two angles right here, right? Or these two angles right here. So I'll give you guys as long as it takes to copy this down. It's very important. I've got a diagram here with four angles, okay? So somebody tell me a pair of vertical angles from this diagram. B and D, good. They're directly opposite from each other. And two more, A and C, right? Those are our two vertical pairs of vertical angles. Okay, so let's do some logic here. First off, can everybody see that A plus B equals 180? And why is that? Because they are what? Supplementary is the word I was looking for, or linear pair, okay? So again, make sure you write down all of these. We're basically about to prove that vertical angles are equal to each other, and it's very simple. I know the word proof can sound like it's going to be pages long. There's just a few lines long. All right, so we're going to do some simple algebra with that. Notice if we subtract b from both sides, we get the fact that, that's a little bit too wide for me, we get the fact that a is equal to 180 degrees minus b. I'll go back in just a second. I want you to see what the diagram looks like. So if we take 180 degrees and we subtract b, we get whatever a is. So for example, if b was 40, we subtract 40 from 180, that would mean a is 140. So 140 and 40 make 180. So it's a simple concept. So again, make sure you get that jotted down. That's the first part of our little proof. If you look at the diagram, C looks like it's going to be 180 minus B as well. Right? So that kind of alludes to how the proof works. So we know that C plus B equals 180, right? Because they are also supplementary. So if C plus B equals 180 and we subtract B from both sides, we also get the fact that C is equal to 180 minus B. So if C is equal to 180 minus B and A is equal to 180 minus B, then how do A and C relate to each other? They're equal. So here's how it works. If they're both equal to 180 minus B, then they must be equal to each other. In other words, A must be equal to C. Now the property we're using there is called transitive property. Transition, right? 180 minus B is the transition from A to C. So therefore, and I will go back up so you can write this down, but therefore we can show then that A is equal to C. Okay, so now that we've shown that A is equal to C, we can go back to the diagram, make these two little orange marks. The orange marks means they're equal. When you make a little, I don't know what you would call it, maybe an arc, like a mini arc, that's saying that those two angles are equal to each other. So we've actually just proven that for any two vertical angles, they're going to be equal to each other, no matter what. We didn't assign any angles to them, right? We didn't say they were 30 or 40 or whatever, 170. So on your diagram, just make these two little orange marks or arcs. And make sure you write this word down, and I'll give you a second to copy it down. But basically, when we talk about angles being equal to each other, we usually use the word congruent, and we use that little arc. Okay? And that just means that they're equal to each other. Now we're going to focus on B and D. The proof is going to go very similar. So now we need to prove that B and D are equal to each other. In other words, we're trying to prove that both pairs of vertical angles are equal. So here's the first part of the proof. We can also similarly show D plus A must equal 180 because they also form a linear pair. And if we subtract A from both sides, we get D is equal to 180 minus A. What other angle can we show is equal to 180 minus A? B. If I take 180, subtract A, let's say A is 100, then I would get B is equal to 80, right? Because 80 plus 100 equals 180. So it's reverse addition. So similarly, if we say B plus A equals 180, and we subtract A from both sides, then we can then show that B is also equal to 180 minus A. All right, so since D is equal to 180 minus A, and B is equal to 180 minus A, we can use a similar argument like before. What's the name of that property? Transitive, thank you. So therefore, D must also be equal to B. Yes, I will. Right there. So, when you already have two angles equal to each other, the way to denote the next two is to use two arches. And after that, you just use 3 and 4 and 5, and that way we can look at a diagram quickly and see which angles are equal to each other. If we just put one arch on B and D, then that would be saying that they're all equal to each other, right?
Then we get confused.
Yes, and we don't want that. So again, that keyword is congruent, and can use as many as we need. I think once you get to 3 or 4, you should probably draw a new diagram, because then it's just really hard to read. It's too tedious to distinguish everything. But certainly 1 and 2 is easy to tell. And this is some basic stuff. We'll see some more tedious. Simple. We've just proven that vertical angles are always equal to each other. So as long as they're opposite the x, like this, so let's say we have an angle here and an angle here, right? Or if we have an angle here and an angle here, those angles will always be equal to each other. So let's look at the first equation. Somebody tell me how A and B are related. We just proved they're vertical angles, so they're what? Equal, thank you. So with that in mind, we can take this equation, which is an angle, and set it equal to this equation, which is an angle. And that's all you're doing today. You're literally taking two vertically angled equations or expressions, and you're setting them equal to each other. So the question's asking, you need to write this down. What is the measure of angle A? Angle A. So whenever you're solving a vertical equation, that's the first thing you're going to do. You're going to set those expressions equal to each other, just like she said. Okay, that's your step 1. And of course, you don't really have to do this, but A is the 2x plus 3, and B is the 12x minus 2, and they're equal to each other because they're vertical angles. So I'll give you a second to jot that down. The next thing we're going to do is solve for the variable. Solve for the variable. So let me move up just a little bit so we can see the equation. Remember, there's a lot of different ways to solve an equation like this. So I'm just going to show you one way. Basically, you want to get everything that has an x term on one side, meaning these two, and then get everything else, the numbers, on the other side. What I would do here is I would add 2 to both sides. Now again, that's not the only thing. It's not the only way to do it. You could subtract 3. You could do a number of things for the first step. I'm just going to add 2. So the 2 and the 3 are on the same side. So we'll have 2x plus 5 is equal to 12x. And then, of course, we want to get the x's on the same side, so I'm going to now subtract 2x from both sides. That way I have a number on one side and a term with the x on the other. And it will look like 5 is equal to 10x. Thank you, sir. Or no. All right, so what would you do from here to solve for x? Somebody raise their hand and tell me. Layla, thank you. Divide by 10. That way the x will be by itself, okay? So what do you get x is equal to? 1/2. 5 over 10 simplifies to 1 over 2. If you divide the top and bottom by 5, you get 1 over 2. Leads us to the final step, just 3 simple steps. You're going to plug that back into the angle equation or expression. This is asking to solve for A, so we need to plug that 1/2 back into the A expression, which is 2x plus 3 degrees. Okay, so A is equal to 2x plus 3, but we know that x is equal to 1/2, so guess what? We can just simply replace x with 1/2, just like that. And normally you're not going to get this small of an angle. Of course it exists, right? I mean, 4-degree angles are very small, but they do exist. What would you do from here? What's 2 times 1/2? 1 plus 3. And, of course, it's in degrees. Make sure you have your units. Final answer, what's the measure of angle A? 4 degrees. At least write the example down. Yeah. All right, now we have A is equal to 6x degrees and B is equal to 3x plus 81 degrees. So again, this one's a little bit different. Same steps though. All right, so what we're going to do. Now this one's, just keep in mind, this one's solving for B. Doesn't matter, right? They're the same. So A is equal to B, B is equal to A, either way. So we're going to set them equal to each other. So 6x equals 3x plus 81. You need to write the example down. Yeah, just work through it. You don't have to write the steps down. You can label it step 1, step 2. Okay, from here, what are you going to do? Somebody raise their hand. Jessica. Close. Yeah. So the 3x is positive, right? So we got to do the reverse. Subtract it. So you get 3x equals 81. Okay. Now what? Very good. Divide both sides by 3, so the 3's cancel. Not 67. Does anybody know what 81 over 3 is? Close. 27. Remember, there's 3 steps. Now that we've solved for x, what are we going to do with that number? Plug it back in, right? And actually, since they're vertical, it actually doesn't matter what expression you plug it into, right? You should get the same thing back. But I guess for the sake of consistency, since we're solving for b, we'll plug it into this one. So b is equal to 3x plus 81. This is step 3, plugging it back in, but we can do it up here. B is equal to 3x plus 81. So I'm going to replace x with the 27. All right, so what's 3 times 27? We kind of just determined that. 81, yeah. So we get 81 plus 81. What is 81 plus 81? Good, 162. Remember the answer's in degrees. Original diagram, then we could relabel this as 162 because that's what we just found it to be, which would also be angle A. All right, final example for now. It says angles A and B are supplementary